Friends, in a previous time or previous lecture, we will be learn about the definition of the set, and then after them we will be learn the first exercise of the set. Today we have discussed the types of the set. How we can find out the types of the set? We know them when we have collect the collections, and in that collection when we have say the elements, then we have say about it that collection it is a set. That means if the elements are well defined in a collection, that collections we have got the set. Then according to that element we can find out the types of the set, and that is why the types of the set is totally depends on how many number of the elements are come in that set. The types of the sets are depends on the number of the elements in the set. So the first type is the null set or empty set. First type is a null set or empty set. So let us discuss about this few examples in that null set or the empty set. Example. First example. The set of parallel lines intersecting point. The set of parallel lines intersecting point. The two parallel lines are intersect to each other? Never. They are not intersect to each other. When the two lines are never intersect to each other at any point, that is why we have called them it is a parallel line. And that set, the set of the parallel line is an intersecting point. In that set, no elements are in them, and that is why we have called it is a null set of the empty set. No point of intersection. No point of intersection, and that is why that set we have called them it is a null set or empty set. We have get the another second example. Which is the second example we have get? The natural number between the natural number between 2 and 3. The natural number between 2 and 3. The numbers are in between 2 and 3? Never. Yes, the numbers are in between 2 and 3, but it is the decimal form of that number, and it is not a natural number, and that is why we have no say about it. No any numbers, and that is why we have called it is a null set of the empty set. So according to that two examples, we can find out the definition of the null set. Which definition? What is the definition of the null set? The set in which no any elements are in them, that set are called as the null set. In the first example, no any intersection point of a parallel line. That is why in that set no any elements are in them. In the second examples, the natural numbers in between 2 and 3, 2 and 3 are the neighboring numbers and they are the natural one, and no any numbers are in them, and that is why no any number in them, that means the set in which no elements are in them, that set are called as the null set. So the definition is that the set in which no any elements in them are called null set or empty set. We have indicated that null set or empty set by using a specific symbol. By using symbol phi, by using symbol phi, we have indicated by using the symbol phi, we have indicated the null set or the empty set. This is the first type of the set, that is the null set or the empty set. मागच्या तासाला आपण अभ्यास केला आहे की आपण संचाची व्याख्या, संचामधील घटक, संच लिहिण्याच्या पद्धती, त्यानंतर आपण पहिला सराव संच प्रॅक्टिस सेट 1.1 याचा अभ्यास केलेला आहे. आज आपण टाइप ऑफ द सेट म्हणजे संचाचे प्रकार अभ्यासणार आहोत. मग संचाचे प्रकार कसं काय पडतात, तर आपल्याला माहिती की ज्यावेळेस आपण एखादा समूह गोळा करतो आणि त्या समूहामधील घटक आपण सुस्पष्टपणे निश्चित सांगू शकतो, तर त्याच समूहाला आपण संच असे म्हणतो, म्हणजे संचामधील घटक. मग याच घटकांवरून आपण संचाचे प्रकार पाडू शकतो, आणि म्हणून पहिला जो प्रकार आहे तो पहिला प्रकार म्हणजे नल सेट किंवा एम्प्टी सेट. मग नल सेट किंवा एम्प्टी सेट म्हणजे नेमकं काय, तर नल एम्प्टी म्हणजे काय, तर रिकामा. मग ज्या संचामध्ये एकही घटक नाही त्या संचाला आपण काय म्हणतोय, नल सेट किंवा एम्प्टी सेट म्हणतो. मग त्यासाठी आपण उदाहरण पाहिले की दोनच पॅरलल लाईन्सचा इंटरसेक्टिंग पॉइंट पॉसिबलच नाही. दोन पॅरलल लाईन केव्हा असतात की जर समजा दोन लाईन्स परस्परांना कुठल्याही पॉइंटला इंटरसेक्ट करत नसतील तरच त्या पॅरलल्स होते. म्हणजेच पॅरलल लाईन यांचा इंटरसेक्टिंग पॉइंट येणारच नाहीये, म्हणजे त्या सेटमध्ये एलिमेंट येणारच नाहीये, आणि म्हणून आपण त्या सेटला काय म्हणतो, तर नल सेट म्हणतोय. आणि म्हणून या एक्झाम्पलवरून आपण व्याख्या करता येते, द सेट इन विच नो एलिमेंट्स इन देम आर कॉल्ड द नल सेट ऑफ द एम्प्टी सेट. मग ज्या संचामध्ये एकही घटक नसतो त्या संचाला आपण नल सेट किंवा एम्प्टी सेट असे म्हणतो. मग एम्प्टी सेट हा एका विशिष्ट सिम्बॉलने इंडिकेट केला जातो. मग कुठल्या सिम्बॉलने इंडिकेट केला जातो, तर या सिम्बॉलने, याला फाय आपण या अक्षराने दर्शवत असतो. मग एम्प्टी सेट हा फाय या अक्षराने किंवा या सिम्बॉलने इंडिकेट केला जातो, दर्शवला जात असतो. द सेकंड टाइप ऑफ द सेट इज अ सिंगलटन सेट. सिंगलटन सेट इन मराठी एक घटक संच. Okay, we have get some different examples of the singleton set. So we have get the different examples of the singleton set. A set of even prime number. A set of even prime number means only a one number, even number is also and the prime number is also, and that is why the answer is only 2. The only one, 2 is the even prime number. That means 2 is an even number also and 2 is a prime number also, and that is why in that set we can collect only a one single element, and that is why that set we have called it the singleton set. So why we have called them it is a singleton set? In that set when we have collect the element, we have get the only single number of the element in them, and that is why that set we have called them it is a singleton set. So the definition is that the set in which only one element are in them, the set in which only one element are in them, that set are called singleton set. The set in which only one element are in them, that set are called singleton set. सिंगलटन सेट म्हणजे एक घटक संच. एक घटक संच म्हणजे ज्या समूहामध्ये किंवा ज्या संचामध्ये फक्त एकच घटक आला पाहिजे त्यालाच आपण एक घटक संच असे म्हणतो. उदाहरणार्थ आपण पाहिलं आहे अ सेट ऑफ इव्हन प्राइम नंबर. इव्हन प्राइम म्हणजे काय तर सममूळ संख्या. सममूळ संख्या म्हणजे जी संख्या सम पण पाहिजे आणि मूळही पाहिजे. तर 2 ही अशी एकमेव अशी संख्या आहे की जी सम पण आहे आणि जी मूळही आहे, आणि म्हणून या समूहामध्ये फक्त 2 हा एकच घटक येतोय, आणि म्हणून आपण या संचाला काय म्हणतो तर सिंगलटन सेट म्हणतो. आपण त्याला एक घटक संच असे म्हणतो. मग हा झाला संचाचा दुसरा प्रकार. सो द नेक्स्ट इट इज अ थर्ड टाइप, and the third type is a finite set. Finite set, that means in Marathi we have called it is a Santa Sancha. So finite set means what? We have get some examples. Example means the color of rainbow. We have count them. Red, orange, yellow, green, blue, indigo, violet. How many they are? There are 7 in 1. The color of the rainbow, we have count them and they are 7 in 1. We have get the another different examples. Another different example is that the number of bones in adult bodies. 206. We have count them. We have easily count that numbers. How many number of the bones in them? 206 bones in them. We have easily count them. Then third example. The distance between any two places. Countable. We have easily count the distance between any two places, and that is why we have say about it. If we have easily count the how many number of the elements in a set, that set we have called it is a finite set. How many number of the elements in a set, and if we have easily count them, then we have called them that set is a finite set. And according to that three examples, we have get the definition of the finite set is that the set in which we can count the number of elements in them, the set in which we can count the number of elements in them, that set are called finite set. That set are called the finite set. फायनाईट सेट म्हणजे शांत संच. शांत संच म्हणजे आपण त्यासाठी एक्झाम्पल घेतलेले. एक्झाम्पल म्हणजे द कलर ऑफ द रेनबो, इंद्रधनुष्यामधील कलर. व इंद्रधनुष्यामध्ये कोणते कोणते कलर असतात आपल्याला त्यांची नावं माहिती. कोणती कोणती नावं आहेत तर रेड, ऑरेंज, येलो, ग्रीन, ब्ल्यू, इंडिगो, व्हायलेट. किती झाले एकूण 7 कलर झाले. देर आर 7 in 1 म्हणजे रेनबोमध्ये 7 कलर असतात हे आपल्याला माहिती, आपण मोजू शकतो. त्यानंतर द नंबर ऑफ द बोन्स इन अडल्ट बॉडीज, एका पूर्णपणे वयस्क किंवा मोठ्या झालेल्या माणसाच्या किंवा ज्याच्या शरीराची पूर्णपणे वाढ झालेली आहे अशा बॉडीमध्ये, अशा माणसाच्या शरीरामध्ये 206 आड असतात हे आपण मोजू शकतो. त्यानंतर द डिस्टन्स बिटवीन द एनी टू प्लेस, जर तुम्हाला कुठल्याही 2 जागा दिल्या किंवा 2 प्लेसेस जर समजा तुम्हाला ठरवून दिल्या आणि त्याच्यामधलं जर समजा तुम्हाला अंतर मोजायला लावलं तर तुम्ही ते मोजू शकता, तुम्ही ते सांगू शकता. म्हणजे याचा अर्थ जर आपण एखाद्या समूहामधील घटकांची संख्या मोजू शकतो तर त्या संचाला आपण शांत संच असे म्हणतो. आणि म्हणून डेफिनेशन येते the set in which we can count the number of the element in them, that set are called finite set. मग ज्या संचामधील घटकांची संख्या आपण मोजू शकतो तर त्या संचाला आपण शांत संच असे म्हणतो. हा जरा संचाचा तिसरा प्रकार. आता एक शेवटचा प्रकार आहे तो म्हणजे चौथा. So the fourth type of the set is a infinite set. Examples. It's a many different number of the examples of an infinite set. For example, set of natural numbers. Can we count the natural numbers? No, because of natural number is a infinite. Set of whole numbers. Whole numbers is also the infinite. Set of integers. Set of integers is also the infinite. And that is why when we have understood that all three examples, we have find out a simple conclusion is that if the number of the elements in a set is infinite, that means we are never count them, that set is called as the infinite set. And that is why the definition of the infinite set is that the number of elements in the set is infinite, or we are never count them, are called infinite set. The example of them, all these are the three ones. इनफायनाइट सेट, अनंत संच. अनंत संच म्हणजेच काय, जर आपण तीन वेगवेगळे उदाहरण जर पाहिले तर तीन वेगवेगळे उदाहरण म्हणजेच आपण नैसर्गिक संख्यांचा समूह. नैसर्गिक संख्या किती आहेत आपल्याला मोजता येणार नाही, अनंत नैसर्गिक संख्या. त्यानंतर पूर्ण संख्यांचा समूह, अनंत आहेत पूर्ण संख्या. पूर्णांक संख्यांचा समूह, अनंत आहेत पूर्णांक संख्या. जर समजा कधी तुम्ही रात्री आकाशामध्ये जर समजा कधी तारे मोजण्याचा प्रयत्न केला, चांदण्या मोजण्याचा प्रयत्न केला तर तुम्हाला मोजता येईल नाही, अनंत आहे. मग ज्या समूहामधील घटकांची संख्या आपण मोजू शकत नाही किंवा ज्या समूहामधील घटकांची संख्या अनंत असते तर त्या समूहाला, त्याच संचाला आपण काय म्हणतोय, अनंत संच असे म्हणतो. मग हे चार संचाचे मुख्य प्रकार आहेत. त्यानंतर संचाचे उपप्रकार पडतात. मग ते उपप्रकार आपण एक एक करून जाणून घेऊया. नाउ द फिफ्थ टाइप ऑफ द सेट इज अ इक्वल सेट. We have get the example of the equal set. So the first example, set A. A such that A is the letter of word 10. A such that A is the letter of word 10. B. B such that B is the letter of word net. A such that A is the letter of word 10. B such that B is the letter of word net. These two examples are given in a rule method. When we have converted them in a list method, A is equal to A such that A is a letter of the word 10. 10. How many letters? 3 letters. Which 3 letter? T-E-N. B. B such that B is the letter of the word net. Net. How many letters? 3 letters. N-E-T. Okay. If we have compare them, the set A and the set B, what we have see them? The every letter of the set A and the every letter of the set B are in equal. They are in different in a manner. Arrangement are different, but they are in equal. That means the number of the element, the 3 element in set A, the 3 element in a set B. T-E-N. These 3 alphabet in a set A. T-E-N. These 3 alphabet in a set B. That means the number of the element and the element both are the same in a set A and the set B, and that is why we have find out one last conclusion is that the set A and set B are the equal set. So why we have called them the set A and set B are the equal set? Because of the every element of the given 2 set are equal. That 2 sets are called as the equal set. In that both examples, in about both set A and set B, show same number of elements in them and every elements are also same, therefore they are equal set. Therefore they are equal set. So we have find out the definition is there. Definition is there. In a given 2 or more than 2 sets, in a given 2 or more than 2 sets, the every element are same. The every element are same. That sets are called equal sets. That sets are called equal sets. Symbolically, we can write down them symbolically we can write down then set A is equal to set B. Set A is equal to set B. So we have complete some concept of a types of the set. Then after them we have start the practice set number 1.2.